In this video, we'll talk about Carl Friedrich Gauss. He's a German mathematician who was born in 1877 and died in 1855. He's an icon in mathematics as well as in physics. Great story about him while he was still 7 years old. Friedrich Gauss was hyperactive. To make him behave, his teacher gave him a punishment. And the punishment was to solve this series. And up to 100. Let's start from adding 1 to 10 first to see the pattern. Okay. So this is how we did it. He paired the numbers cleverly, like 10 plus 1 is 11, then 2 plus 9 is 11, 3 plus 8 is 11, then let's pair it here, 4 plus 7 is 11, 5 plus 6 is 11. So how many 11s there are? 1, 2, 3, 4, 5. There are 5 11s. So the formula for this small number is simply 5 times 11, or just 10 plus 1. Okay? 5 is just simply half of the last digit, which is 10. So if you look at it, it looks like 10 over 2, it gives the 5, and then the last digit is 10, you add 1 to it. Okay, let's look at it in a bigger perspective. So let's go back to this problem here. 1 plus 2 plus 3 plus 4 up to 100. Now let's let this equal to S. And let's do the same as what Gauss did here. Let's pair last digit to the first digit, but we'll do it like this instead. So 1 plus 100, then before 100 is 99, we add it to 2. Before 99 is 98, we add it to 3. And then here's 97, here's 96, and then it finally comes down to 1. So let's take this as S as well, because it's the same. It's just only the reverse of the 1 on the top. Now let's add this together. This is 101. Add another 101. Add another 101. Add another 101. So on and so forth, up to another 101. On the left side gives us 2s. Now, how many 101 are there? That's 1 up to 100, so there are 100, 101. And that's equal to 2s. Now let's divide this by 2. That gives us s equals 100 plus times 101 over 2. So this is the working formula that Gauss came up, and that surprised his professor as well. So this is the equation who came up if we add 1 to 100, the formula would go like this. We have 100, then multiply it to 100 plus 1, then divide it by 2. So in this, if you look at here above, this is the general formula for any number n. It's not only 100, but for any number n. And it goes with the same pattern. If our last number is n, then we have n here, and then multiplied it to n plus 1, and then divide it by 2. So that's the same pattern we get. Now let's solve this general formula. The idea is still the same. We let it equal to s, adding this series. Okay, before n, you have n minus 1, or maybe n minus 2 first, plus n minus 1 plus n. Of course, before n minus 2, you have n minus 3, and so on and so forth. And then we add the same series below, but we reverse the terms. That is going to be n here, and n minus 1 plus n minus 2, reversing the, what's the sum? Okay, it's not included. It's supposed to be 4. And then n minus 3 plus n minus 4, so on and so forth. And then you end up, of course, the last term should be 1, then here 2, then here 3. So let's add these two sums together. The left side is 2s, and the right hand side you have n plus 1. Okay, and then if you add this, n minus 1 plus 2, that's 2 minus 1, it gives you 1. So that is n plus 1 as well. And you add this, 3 minus 2, that is 1. So that's n plus 1. And the rest of these terms will follow the same. And then let's continue until here. Still the same. 3 minus 2 is 1. So that's n plus 1. Here, the same, n plus 1. And of course, that's n plus 1. How many n plus 1 we added together? You see this? That's 1 plus 2 plus 3 up to n. So there are n terms of it. Therefore, this is 2s equals n terms, or n times n plus 1. So solve only the s, because this is the original one, because this is the sum that we really want to get. We divide to both sides. And finally, we get the formula n plus 1 over 2. So this is now a working formula for any number n. So your n could be any number. It could be 1 million, could be 1,000, or whatever it is.